Hello, in this lecture we are going to understand about the idea of limits. To understand the idea of limits, first we'll try to understand the neighborhood of a real number. Let's consider a real number a and think about the smallest interval in which a can lie. Well, the smallest interval depends upon how close we can move to a, either from the left side or from the right side. Since there is no measure how close we can move to a number, we assume that a lies in an interval a minus h, a plus h, where h is infinitely small positive real number. It's infinitely small positive real number. So all the numbers lying in this interval a minus h, a plus h, all are the neighborhood of a. Suppose a number x which is very close to a but not exactly equal to a. So we can say that in this case, if it is very close to a, we can say that x approaches to a, or we use the notation to show x approaches to a. Let's understand the limit of a function. Let's consider a function f of x which is x squared minus 4 over x minus 2. It's not defined at x is equal to 2 because if you substitute x with 2, you get 0 by 0, and this is an indeterminate form. It's an indeterminate form, so it does not have any answer. There are 7 indeterminate forms. Those are 0 by 0, it's infinity by infinity, 0 times infinity, infinity minus infinity, 0 to the power 0, infinity to the power 0, and 1 to the power infinity. All these are indeterminate form, but the 0 by 0 is the fundamental indeterminate form because all others can be reduced in form of 0 by 0. Since we don't have any answer for x is equal to 2 for this function, so we'll try to take the positive smaller and the greater number but close to 2. So when the x approaches to 2 from the left side, or you can say if we increase the value of x from the left side, the function is getting closer to 4, like 3.456789. You can see here it's 0 by 0, but it seems to be 4. So we can say that when x approaches to 2 from left side, from left hand side, the function f of x tends to limit 4. So we use the notation to show x approaches to 2 from the left side. So f of x approaches to 4. Or we can write limit x approaches to 2 from the left side, f of x is equal to 4. Now this value, when we are increasing the value of x, we are approaching from the left. So this value, this is called the left hand limit, or we call it LHL. This is called left hand limit or LHL. You can look at the table. When we approach 2 from the left side, the value of x is decreasing, but again the f of x is getting closer to 4. So we can say that when we approach x when x approaches to 2 from the right hand side, and then also the f of x approaches to 4. So here we can say that limit x approaches to 2 from the right side, f of x is equal to 4. And this is called the right hand limit, or we call it RHL. In this particular case, when we approach from the left side and the right side, the f of x tends to limit 4. So we can say that the left hand limit is equal to right hand limit. Any function exists, the limit of a function at a value exists only and if only. So limit x tends to f of x approaches, f of x exists if the limit x tends to 2 from the left side is equal to limit x tends to 2 from right side are equal. So because here the LHL and RHL are equal, so the limit of the function at 2 exists and that's equal to 4. From the graph also we can understand what is the neighborhood of 2. Let's take another function which is absolute function x minus 3 over x minus 3. Obviously it's not defined at x is equal to 3 because the f of 3 gives you 0 by 0, which is again an indeterminate form. And you can see the table putting different values. So when x approaches to 3 from the left side, the value of x is increasing. It's 2.34567 up to 9. But the value of f of x is constant. It's still negative 1 in all the conditions. But when the x approaches 3 from the right side, the value is positive 1. So here we can see that when x approaches to 3 from the left side, the f of x tends to limit negative 1. But when the limit approaches x approaches to 3 from positive side, f of x approaches to positive 1. So here we can say that the limit exists for this particular value. So we can say that limit x tends to 3, f of x does not exist. And the reason is that the LHL is not equal to the RHL. The LHL, the left hand limit, is not equal to the right hand limit. Let's see another example of the function which is 1 over x minus 4. It's also not defined for x is equal to 4. So as we increase the value of x, or we approach from the left side, so when x approaches to 4 from the left side, the function tends to limit negative infinity. And when the x approaches to 4 from the right side, you can see that this is also pointing towards the infinity. So f of x tends to limit to positive infinity. Here neither value at x of the function nor the LHL and RHL exist. So we can say that RHL and LHL both does not exist. So we saw three cases. In the first case, the value of the function at that particular value does not exist, but yes, the limit at that value exists. In the second case, we saw that the LHL and RHL are not equal, so therefore the limit at that value for the function does not exist. Similarly, in the last one, neither the value of the function at that particular value nor the LHL and RHL exist. Let's see some real life problems related to the limits. Suppose the ball is dropped from the upper observation deck of CN Tower in Toronto, 450-meter above. So it's 450-meter above the ground. Find the velocity of the ball after 5 seconds. So model the relation between the position and time. We can say that S of t is 4.9 t squared. Now because we need to find the velocity, and so we can say that the average velocity is equal to change in position divided by time. So the time taken by the object. Here, when we have made a table that what we are doing, we are making the time interval smaller and smaller. So you can see that the first time is between 5 to 6 seconds. The second one is between 5 and 5.1. The third one is 5.05. Then 5 to 5.01. Then 5 to 5.001. As you can see that when as the time interval is getting smaller, or you can say that it tends to zero, the average velocity tends to so the average velocity tends to 49 meter per second. So this 49 meter per second, we can say that it's an instantaneous velocity at t is equal to 5. It's an instantaneous velocity. So the first graph shows the average velocity. P and Q are the 2 points because of the time interval. Suppose P and Q comes closer, 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 and they almost coincide each other. So we get a so passing through that point, if we draw a tangent, that shows the instantaneous velocity.